Hello everybody, my name is Darius Haskell. For those of you in the amateur radio community, my call sign is KC1FNL. Today I'm going to show you how to download images from NOAA weather satellites. Okay, let's begin. So here I have a very simple, I guess you could call it a horizontal V dipole with a 120 degree angle between the elements, and that's connected via coax cable to my computer with a NESDR Smart XTR NOAA dongle, and that's a software-defined radio for those of you who don't know. And the programs I will be using are QFH. I'm sorry for the glare on my screen. I don't think there's any way to avoid that. Okay, so QFH is the program I will be using, along with, let's see here, let me select the dongle. Okay, and so as you can see, we're picking up frequencies here on the computer. Now, the software I'll be using to decode the actual images is called WX to IMG, which is a free software you can download. And here it tells you when the next satellite pass is going to be. So the next satellite will be NOAA 18, and it will be coming over our heads local time at 18:20 and 49 seconds. And right now it is 18:20, so we should tune to that frequency. It's 137.9125. Okay, so just tuning to the frequency here, and I'm setting the correct bandwidth. The mode that the satellite transmits in is called APT, which is also known as automatic picture transmission. And so in just a moment here, you'll be able to hear the signal. So I'm going to set the bandwidth on the QFH program to about 30 kilohertz to start, and as the signal becomes clearer and clearer, I will widen it open to get as much of the signal as possible. As you can hear, the signal is coming in pretty strong now, so I'm going to port it to the WX to IMG program. Okay, so now I'm using a virtual audio cable, if you will, to port the sound output from the QFH directly into the WX to IMG program. And now I am zooming in on the signal. I will take you back over here. So here is the signal of the satellite. Okay, as you can see, I have my bandwidth set to about 36,000 hertz right now, and this is what the APT signal looks like. Again, I'm sorry for the glare on my computer screen. And because the satellite is moving so quickly, we actually experience a Doppler shift, so you have to occasionally just very carefully adjust the center frequency by clicking and dragging, and that way you'll keep as much of the satellite transmission in your bandwidth as possible and get a clear image. So as the data is going, the raw data is going into the WX to IMG program, we can see it displayed, and after the recording is over with, it will run some signal processing on this image and clear it up quite a bit. So now, for the rest of the duration of this satellite pass, I will just carefully keep adjusting my bandwidth and making sure I'm staying on the center frequency. It's quite a nice signal, actually. There's several bands, and as you can see, I'm dealing with a signal right now. So the noise floor is about negative 67 dB, and my peak signals is peaking to about negative 19 dB right now. And again, we can see, so I had some noise at the beginning of the transmission here, and we can see as the satellite is coming closer to being directly overhead, the image is clearing up as the signal gets stronger. As you can see, the signal is getting stronger. We're at about negative 14 dB now. And I will put a link in the description of this video to the where I got this antenna design from. And it's very simple and easy to build. As you can see, I just used some, I think it's about 1/4 inch diameter copper wire to build it, which has a good enough bandwidth at that diameter. And as you can see, very simple construction. All I did was screw it directly into the wood. Oh, I gotta adjust my center frequency there. And you can see where I actually adjusted it, a little bit of noise appeared on the image. So our signal is getting stronger as the satellite passes overhead, and then we'll see it start to fade out here in a couple minutes. This pass in particular, well, I can't access the satellite pass list while the program's recording, but typically the passes last from anywhere from about 9 to 11 and a half minutes or so. Okay, so let's check on our image and see how that's doing. As you can see, we have a fairly nice image so far. Again, this is unrendered. The software will compile it once this pass is complete. And it does, this free software it shows you how far you are through the pass. So I guess we're about 60% through the pass. And all it does is you just put in your GPS location, and it downloads these Kepler files, which contain the information of when this satellite is going to pass overhead. And basically it'll give you exactly when the satellite should come into your field of view over the horizon, and it will tell you the duration of the pass, how long you should theoretically be able to receive the signal from this satellite, you know, as it goes over the other horizon. Now, of course, things like trees and buildings will get in the way of that. So my tall house over here does get in the way of that a little bit, and you know, the trees on the horizon do get in the way of it. So that's unfortunate. I'll have to try this up on a hill sometime where I have a clear view from horizon to horizon. And again, this, like I said, so the satellite signals are known as right-handed circular polarization. So the signals coming from the satellite have a right-handed circular polarization. Now, when you go to Google different antennas you can use for this purpose, the most common design you will find is called a QFH antenna. Now, this QFH antenna is a quad filar helical antenna, and you have to be quite precise when building it. Obviously, I went for a much easier design. I'm not sure how much better that antenna would perform. I have yet to try that out. What I do know is that for the simplicity of this antenna, the result of this image will be quite spectacular. Obviously there will be some noise, but as a whole we'll have a pretty nice image of what's in the sky above us. So in terms of simplicity, it's a very good antenna. We can see as the satellite signal gets weaker relative to the noise around it, we'll start seeing a lot more greenish stuff on our waterfall display here. And we will also notice that a significant amount of noise has been added to our picture. But that's okay, because we're almost complete here with the picture. And in just a moment we will be able to render this with oh, here it goes. Building map. So, as you can see, we did have some noisy spots in our image, but we should be able to get a fairly nice image here in a second as it finishes building the map. Okay, here we go. Now, as you can see, here is what we are looking at. Here I am. The program adds in a little cross where your coordinates are. And as you can see, we're looking at the coast of Maine. So the automatic picture transmission, as you can see, it basically broadcasts where the satellite is flying over. So it's taking, I'm not quite sure how it works, if it takes bits of pictures and transmits that in a stream. But as you can see, the satellite flew over this area, so this is what you're going to get for an image. Now, satellites, they, you know, if it had flown more over Maine, we'd be more looking at this area to the west of Maine. You know, we'd have a nice clear track here. So depending on where the satellite flies over, you can get different views of different areas. Now, as you can see, pretty much no matter where you are on the face of the globe, you can expect to see about, let's see, 3, 6, about 10 passes per day. There's 3 active NOAA satellites, NOAA 19, NOAA 15, and NOAA 18. And these are their respective frequencies, 137.1, 137.62, and 137.9125. But anyways, I just wanted to show you some of the different enhancements we can do on this image. So right now what we're looking at is HVCT false color, whatever that means. So we can change it to multispectral analysis, and it'll take a moment to render the new image, and it'll give us a slightly different look. I don't know if you can really tell, but some of the clouds, I'm assuming at a different elevation level, look a little grayer here. The image as a whole is a little darker. So yeah, it's pretty cool. Here we can get the sea surface temperature enhancement, so it'll take a moment to render that. And as you can see, we'll get some nice coloration here showing the temperature of the seawater, because these satellites do take pictures in infrared as well. So, as you can see, where there is a lot of noise in the image, though, it won't be very accurate. Okay, that's all I have to say for now. I hope you've enjoyed watching. This is my first video I've made of any sort that I'm going to post on the internet. So I hope you've enjoyed watching, and have a good day.